Hi, I'm just going to make a quick video to help you with a couple of homework problems from homework number 2. Just doing some vector review, which is certainly a good foundation to have in physics. This first problem, number 7, is just asking us to take a vector of magnitude 9.1 meters, which is a length, and at a direction of 195, and break it into components. When you're doing this, there's a couple things to keep in mind. First of all, when we do vector components or vector directions in general, we go counterclockwise around the unit circle. So the positive x direction is 0 degrees, the positive y direction is 90 degrees, the negative x direction is 180, and the negative y is 270. We also refer to this as the first quadrant, second, third, and fourth quadrant. Those quadrants have important meanings for the sign or the direction of the vector components. The first quadrant, anything from 0 to 90, will always have a positive x and a positive y. In the second quadrant between 90 and 180, you'll always have a negative x and a positive y. From 180 to 270, negative x and a negative y, and from 270 to 360, a positive x and a negative y. The angle given in this problem is 195 degrees, which is in the third quadrant. So we expect both our x and y vectors to have a negative direction. If I draw this triangle of 9.1 meters at 195 degrees, and this is just a sketch, I would then make it the hypotenuse of a right triangle. I draw my x leg, I draw my y leg. The little angle in here is 15 degrees, but your calculator understands that 195 is related to 15 degrees, but in the third quadrant. So then I use SOHCAHTOA. If cosine is the adjacent over hypotenuse, then cosine of 195 is equal to x over 9.1. By multiplying both sides by 9.1, I isolate the variable x. X is now equal to 9.1 cosine of 195, which is equal to negative 8.79 meters. The negative is the direction, the 8.79 is the magnitude. To find the y leg, we use sine, because the y leg is always drawn second, which will always make it the opposite leg. So sine of 195 equals y over 9.1 meters. Multiply both sides by 9.1 to get negative 2.36 meters. It's important to make sure your calculator is in degrees, not radians, or you'll have answers that really don't make sense. Okay, so the next problem you asked about was number 8, which has 3 different vectors. A car is driven east for 47 kilometers, then north 32 kilometers, and in a direction 26 degrees east of north, which is a funny way to give the angle, for 30 kilometers. Draw the vector diagram and determine the total displacement of the car. Well, first I just sketched the 3 vectors. Here's 47 kilometers east, 32 kilometers north, and 30 kilometers 26 degrees east of north, which is really strange because we don't usually give angles that way. If I draw the vector diagram, and this is just a sketch, notice that I've actually marked the angle as 64 degrees because we measure all angles relative to the positive x-axis going around. So I break each vector into components using cosine and sine, which I explained in the last problem. Although when you have a vector on an axis, you don't really need to break it into components. Although if this is 0 degrees, 47 times the cosine of 0 is 47, and 47 times the sine of 0 is 0. Likewise, if I take 32 times the cosine of 90, I'll get 0, and if I take 32 times the sine of 90, I'll get 32. I don't really need to use trig to break these into components. I can really just use common sense. The last vector is not on an axis, so I do need to use trig, specifically cosine for the x leg and sine for the y leg. So 30 cosine 64 is 13.15, and 30 sine 64 equals 26.96. Be careful here. If you use the 26 degrees, you'd have to be very careful about what's your adjacent leg and what's your opposite leg. Now the reason why we put all our x's here and all our y's here is that vectors on the same axis add like directed numbers. So everything that's horizontal we can just add like a number. Everything that's vertical we can add like a number. So the total x displacement is 60.15 and the total y displacement is 58.96. Now we have a giant right triangle. Well, to find the actual displacement, or this line, we use Pythagorean theorem. A squared plus b squared equals c squared. In this case, to find the hypotenuse, we'll take the square root of the x leg squared plus the y leg squared to get our total displacement. To find theta, we use tangent. Tangent is opposite over adjacent. So in general, we put the y over the x leg. The tan inverse of 58.96 divided by 60.15 is 44.4 degrees. Here are my basic steps for vector addition. Break the vectors into components using cosine and sine. Add your x's and y's, taking careful measure if there's positive and negatives, you need to include those. Once you have a total x and a total y, you will now have a right triangle. So go ahead and use the Pythagorean theorem and then do tan inverse to find your theta. In the next problem, we'll see why sometimes you need to be careful with theta, especially if your final vector is not in the first quadrant. In number 9, we have someone who goes north, then west, and then south. And they ask us to find the direction a bird would fly in a straight line from the same starting point to the same final point, which is basically saying what's the displacement. So I think the nice thing about this problem is the big idea is sometimes theta is not so simple. You need to figure out how to put it in the first, second, third, or fourth quadrant depending on the signs of your components. Here's a general rule that I use for what to do with the first, second, third, and fourth quadrants. So for this problem, we use cosine and sine, although really we don't need to because all of the vectors given are on an axis. So I take the first vector, the second vector, and the third vector, and I write it in form of x and y components. If using cosine and sine helps you, go ahead. So I add these up and I get a negative 3.1. I add these up and I get a positive 3.5. So if I sketch that picture, I get a negative 3.1 pointing to the left and a positive 3.5 pointing up. So I have a negative x and a positive y. My final answer should be somewhere between 90 and 180 degrees. Now the Pythagorean theorem still works the same because anything negative squared is just as if it was positive. But here's where we need to think. To find this little angle in the triangle, I do tan inverse of ry over rx, and I get alpha equals 48 degrees. But 48 degrees should point something like this, and I know that this needs to be somewhere between 90 and 180. Well, if this is 48 degrees, and the angles on a straight line are 180, to get this piece over here, I'm going to take 180 minus 48 degrees. So my actual final theta is 132 degrees. So all you need to know to put the angle into the right quadrant is that the angles on a straight line are 180 and the angles in a circle are 360. Okay. I'm hoping that will help you to go ahead and try number 10 on your own. If you still need more help, just send me an email. But here we have a final destination of 4.1 kilometers and a direction of 40 degrees north of east. So that puts that in the first quadrant. Go ahead and use sine and cosine to break this into components so that you're using cosine to find the x leg and sine to find the y leg. Hope that helps.